Hello everyone, I am Kumar S. Currently working as an embedded systems intern at EMERTXE. During my internship, I had the opportunity to work on a washing machine simulation project, which helped me apply and enhance my technical skills in embedded systems. In this video, I will be giving you a comprehensive overview of all the key topics I have learned during my internship. I will also walk you through the project I worked on, highlighting its functionality, design, and the concepts involved. Let's begin by exploring the topics covered during this internship and what you can expect in this video. Let's go to the overview of this internship. We have goals of this internship: embedded C programming, embedded systems, types of embedded systems, project requirements, tools used in this internship, design and board selection, and implementation of the project, and at final conclusion. Goals of this internship. So every internship has a goal, uh, and this internship has some goals to gain knowledge about embedded systems and embedded C programming and gain a hands-on practice. To gain hands-on experience on real-world projects on embedded systems. To build a real-world scenario projects such as washing machine using microcontroller and embedded C programming. What is embedded C programming? Let's discuss about embedded C programming. Embedded C programming. Embedded C programming is a simple version of the C programming language, and it is used to program small electronic devices like washing machine, remote controls, sensors. It helps control hardware by writing code that tells the device what to do, and it's fast, efficient, and works well with microcontrollers and embedded systems. And the topics involved are we have discussed in this internship are data types. So in data types we have character, float, integer, and double. And the next one is modifiers. And in modifiers we have signed, unsigned, and short and long. And then qualifiers. And in qualifiers we have constant and volatile. And then loops. And in loops we have for loop, while loop, do while loop, and then jump. And in jump we have go to statement and break statement and continue statement. And then decision. And decision we have if else and switch case default. And then storage class. And then storage class we have auto, register, static, and external. And then derived. And in derived we have struct and unions. And then user defined data types. And user defined data types we have enums and type diffs. And then arrays and pointers. And we have discussed the functions. So we also know function is a reusable block of code, and it performs a specific job, executes the defined set of instructions, and it can be called any number of times. We know once a function is represented or defined, it can be called any number of times, many number of times in the program, and it is easy to understand and debug. And strings are sequence of characters ends with a null character. And macros, so macros are defined using hash defined directive. Remember, macros are defined using hash defined directive and processed before the actual compilation begins. And using macros, we can define a name that gets replaced with a specific value throughout the program. And let's get into the embedded systems. So, uh, the definition of embedded systems is an embedded system is a combination of hardware and software which is intended to do a specific task. So, it is a combination of hardware and the software, so which is designed or which is intended to do a specific task. And an embedded system is a computer system designed to perform a specific task within a larger device. And it includes processor, memory, and input output. and is often used in real-time applications. So the embedded systems are used in real-time applications such as washing machine, ATMs, microwave ovens, and smart TVs. And nowadays, we are using most of the real-time applications of embedded systems. So these embedded systems are classified into some types based on their performance and functional requirements. So they are standalone embedded systems, real-time embedded systems, network embedded systems, and mobile embedded systems. And these real-time embedded systems are again classified into soft real-time embedded systems and hard real-time embedded systems. Let's go through this. Standalone embedded systems. And standalone embedded systems operates independently without needing a host system such as computer or external processor, directly displaying data or making changes on the connected device. The input is received through ports in the form of analog or digital signals. After performing the required calculations and conversions, the output is shown on a connected device. Various examples are washing machines, mobile phones, etc. And the second one is a real-time embedded systems. When an output is required at a particular time, real-time embedded systems can be used. In this, the real-time embedded systems is used in the situations which is to be which, it is a task. It should be it should have a time and it should be completed within a deadline. So at that time, we use real-time embedded systems, and the system is more suitable for the tasks that have to be completed on time or when there is a deadline for a task. And it has two types: soft and hard real-time embedded systems. Soft real-time embedded systems. In soft real-time systems, the focus is primarily on completing the processes. Meeting deadlines is not critical in this system. So, in real-time embedded systems, it focuses on completing the task within the deadline. But in soft real-time embedded systems, it focuses on completing the task, but it not have a specific deadline. It doesn't focuses on meeting deadlines. The key requirement is that all tasks must eventually be completed. So the main task of this soft real-time embedded systems is to complete the task, is to complete all the tasks. That's it. However, deadlines should still be met whenever possible to maintain system performance. The example of this soft real-time embedded systems are audio system in a computer, and hard real-time embedded systems. Strict adherence to deadlines is crucial and must never be violated. Tasks must be executed correctly on very first attempt without delays. Timing constraints are absolute and must always be met. And the example of hard real-time embedded systems is air control system, aircraft control system. And the third one is network embedded systems. Network embedded systems involve programs operating within devices that are interconnected, typically managed by a microprocessor or microcontroller. These systems rely on networks, which may be either local area networks or a wide area networks. These terms, LAN and WAN, which comes from the wireless communication technology. So, wireless communication technology is a technology where the transfer of information from one place to another place without using any physical media and using and transmitting the information using electromagnetic waves. And in wireless communication technology, it involves LAN and WAN technology. LAN means local area networks and WAN means wider area networks. And office or tech box security systems are typical examples where devices are linked through a centralized network and managed collectively. And the fourth one is mobile embedded systems. Mobile embedded systems refer to portable devices that operate using embedded technologies. Despite having limited memory and features, their ease of portability makes them widely useful and accessible. So these mobile embedded systems have many real-time applications such as laptops, calculators, etc. And now let's get in the project requirements. So the requirements are necessities for the project. So First and mostly requirements for the project are the, this project focuses on simulating a washing machine using a PiximLab software and aiming to replicate the real world washing machine functionality in a virtual environment. So PiximLab is a software, and by using this software, uh, we can observe the virtual operating washing machine functionality, which replicates the real world washing machine functionality. And using various switches in the keypad, we do operations on washing machine. And using CLCD, we can display options and time left to complete the process. And using timers, we track time left to complete the selected process. And using motor, we represent the ongoing process. And using the buzzer, we indicate the door status and the program completion. And the tools used in this internship are, the first one is MPLab XID, and the second one is MPLab XC compiler, that is XC8 compiler, which is integrated with the MPLab XID, which works with integration of MPLab XID, and PiximLab is the third software. And the MPLab XID is a free and cross-platform integrated development environment for programming PIC, DSPIC, AVR, and SAM microcontrollers. And this MPLab XID is a free platform which is not licensed, and we can install in our system and we can use it as free. It doesn't cost a rupee. It provides powerful features like code editing, debugging, simulation, and project management, all within a user friendly interface. And X8 compiler. X8 compiler is a C compiler specifically for 8-bit PIC and AVR microcontrollers. So it is optimized for high performance and supports integration with MPLab XID for efficient code development and debugging. It can supports the integration with MPLab XID, but we have to install MPLab XID and X8 compiler individually. They both are not within the same software. We have to install the two softwares individually. And the third one is PiximLab software. And PiximLab is a graphical simulator designed for simulating PIC microcontroller based circuits and interfacing them with real or virtual hardware. And PiximLab is a software which has a virtual environment which supports the virtual environment, and it allows users to test and debug embedded applications without physical hardware, supporting integration with compilers like MPLab X8. And we use PIC Genius board in PiximLab software, and PIC 16F877A is our microcontroller we have used in this project. So design and board selection for this project, and let's observe the block diagram. Let's observe this block diagram. So in this we have power on, pause, stop, navigation, door status, display, buzzer, motor, and a microcontroller. And we press switch 5 is used to power on the washing machine, and switch 6 is used to pause or stop the operation of the washing machine, and switch 4 is used for navigation, that is to change the menu, to access the elements in the menu. And switch 1 is used to check the door status, and CLCD is used to display the washing machine status, and the buzzer is used to represent the process completion and the door status, and the motor is used to represent the working of the washing machine, and the microcontroller is the main element. And let's come to the pin diagram of the microcontroller we have used in this project, that is PIC 16F877A. So PIC 16F877A is the microcontroller we have used in this project, and this is the pin diagram of the microcontroller. And the board we have used in PiximLab is a PIC Genius board, and it offers visual components like buttons, LEDs, LCDs, and relays, which are essential for simulating a washing machine's control panel and operations. PixSimLab provides reliable simulation for PIC16F877A microcontroller, and which has sufficient IO pins, built-in timers, and ADC modules, perfect for handling the logic and sensor inputs required in a washing machine system. And timers in PIC16F877A. The PIC16F877A has three timers, that is timer 0, timer 1, and timer 2, with a built-in prescaler and postscaler, each serving different timing and counting purposes. And these timers can operate as timers counting internal clock pulses, are the are counters counting external events, making them useful for delays, event counting, and PWM generation, that is pulse width modulation generation. Each timer includes prescaler operations, allowing us to divide the input clock and adjust the timing interval, which is crucial for precise control in time sensitive applications. CLCD in PIC 16F877A. PIC 16F877A contains the CLCD, and the CLCD is typically interfaced with PIC 16F877A using 8-bit or 4-bit parallel communication mode via port B or port D, enabling efficient data and command transfer. And the PIC 16F877A with sufficient IO pins and stable timing control using its timers makes it ideal for displaying messages, sensor values, or system status on the LCD in embedded applications like a washing machine interface. We use 16 into 4 CLCD display and digital keypad in PIC 16F877A. A digital keypad is commonly interfaced with PIC 16F877A using GPIO pins configured in a row column matrix, typically connected to port B or port D. The microcontroller uses a scanning algorithm to detect key presses by sending signals through rows and reading inputs from columns. It enables user interaction in embedded projects such as shuttle wash, modes, or timers in a washing machine project by capturing numeric or control inputs effectively. Let's get into the project details. And this is the interface of the MPLab XIDE software. So in this, we have create I have done the project of washing machine, and which involves the header files such as CLCD header file, and we have defined macros in this header files, and we have digital keypad header file, and we are also defined macros which are required for the digital keypad, and main.h header file, and we have header file for timers, and we have header file for washing machine such as washing machine function definition, and we have source files such as CLCD, and we have write the code in embedded C programming, and this is the code for displaying the contents on the CLCD display in the PixMLab software. So this is the header file that is include main.h, and in main.h we have included all the header files which are required. We have to build the project, build main project, and it displays the build successful. And let's observe washing machine x production.hex. It is the file we have to use in PixMLab software. So this is the PixMLab software. So in this PixMLab software, we have used PIC Genius board and PIC 16F877A washing machine, so a microcontroller, and the file are the code we which have worked in MPLab XIDE is washing machine x production.hex file. Using this, while going to file, so we have a drop down menu and which have load hex, reload lost, save hex, configure, so and some more. So by clicking on load hex, we can load the washing machine dot x dot production dot hex file, and then select the LCD as 16 into 4, and I have taken clock frequency of 20 megahertz. And then this is the Big Genius board, and this is the microcontroller we have used, and these are the switch configurations, and this is a fan, that is a motor, and this is buzzer, and these are tactile switches such as RB0, which is switch 1, RB1, which is switch 2, RB2, which is switch 3, RB, and as same as RB5. So this is the CLCD display which we have been seen the operations of washing machine. So let's go to the implementation of the project. So by clicking on the switch 5, the screen is loading. So it comes to the washing program screen. So in this we have 12 washing programs. So I have coded for 12 washing programs. So by short pressing switch 4, we can navigate through these washing programs such as daily, heavy, dedicates, whites, and stain wash, ecosystems, woolens, bed sheets, rinse plus dry, dry only, wash only, and aqua store. And again, I have coded a loop, so that's why it's coming again to daily. So for demo purpose, I will choose daily. So by a long pressing switch 4, we can select the daily option. So it redirects to water level screen. Now by using switch 4, we can navigate through auto, low, medium, high, and max. I have coded for 5 water levels. So for the demo, I have chosen by long pressing switch 4, I have chosen low. So now the screen has, so switch 5 and switch 6 should switch 5 to start and switch 6 to stop. So I will show you the how to stop the by clicking on switch 6. So it by clicking on switch 6, it will redirect to washing program. So and then again we will start by clicking on switch 5. So we have selected program daily, and the time required for this is, so the function is was. So by clicking on switch 6, we can stop the timer. So by clicking on switch 6, the motor is stops running and the timer is stops. So by clicking on switch 5, the timer and the motor resumes. So for checking the door status, uh, keeps clicking on clicking on switch 1, it displays the door is open, please close the door, by giving a buzzer sound. So again releasing the switch 1, it resumes its operation. So the function runs and the time is going. So program completed. So remove cloth. So it will again redirect to the washing program. So this is a demo. This is the demo of the project, which is titled as washing machine simulation project I have done in this internship. So let's conclude this. Through this internship, I was able to understand the importance of C programming in embedded systems, understand various types of embedded systems, and got to know where each type of embedded system should be used. Use various tools to implement a simulation of a washing machine. Use a microcontroller pick 16F877A. Thank you all. Myself Prem Kumar S signing off.